everything has to be connected today. So especially looking at how do you gain data about the real usage of the vehicle? Because, as I mentioned, so it's all about reducing cost. And at some points, you only can reduce cost if you reduce weight, take away material, reduce sizing of the brake or something like that. And so you have to know what customers or drivers do with your vehicle.
Welcome back to another episode of Point B, a Sibros podcast where we interview industry experts about the latest innovations and trends in automotive technology and the connected vehicle industry.
Welcome to our Point B podcast, where we discuss the future of mobility in transportation products and services. My name is Steve Schwinke, Vice President of Customer Engagement at Sibros. And in today's episode, we're going to talk about what it's like being a disruptor in the mobility industry and the challenges companies face when introducing innovation from the outside. On our show, we have Alexander Rosen, co-founder and powertrain system engineer at DeepDrive. A little bit of background of Alexander. He has over 15 years of experience in the automotive industry with research in wheel hub motors, fault-tolerant electric machines, and manufacturing technologies. Welcome to Point B, Alexander.
Hi, Steve. I'm very happy to be here today.
So let's first start with you providing the audience with a broad overview of DeepDrive and what your technology means to the automobile and transportation industry.
Of course, yes. So we at DeepDrive are a young startup founded in May 2021. We developed a completely new technology. We call it, it's a bit of a technical term. We call it a radial flux dual rotor electric machine. And this, really deep technology has a significant potential in decreasing costs of electric vehicles and increasing range of electric vehicles. So our motor has the potential to increase the range of today's electric vehicles using the same battery size by up to 20%.
Is that entirely within the motor itself, or are there other parts like the rotors that you're providing more innovative technology on to achieve that number?
So it's the whole drive unit. So what we call drive unit is the inverter, so the power electronics, the motor, consisting, of course, of stator and rotor, and either the gearbox or in special cases. So we have to distinguish two cases in our technology. We are going without the gearbox, and then if you take this whole propulsion system or powertrain of an electric vehicle, we with our technology can increase this range by 20%, or vice versa, reduce the energy consumption by 20%.
Are you focused on transportation as well in terms of class 3 through 5 vehicles?
So we are definitely focusing on mass market and passenger cars. So really mainstream applications. So most of our drive units we are developing currently are focusing on mainstream applications like take a Tesla Model 3 or take a VW MEB platform or something like that. So those are we addressing because in this market we see the most or the highest potential to increase sustainability, reduce costs, reduce effort in the transformation of the whole industry towards electric vehicles. The transformation toward electric vehicles is a tremendous task. So in the next 10 to 15 years, we have to exchange the whole fleet worldwide from combustion engine driven cars to electric vehicle driven cars. And that means that we have to produce I think 50 to 60 million electric vehicles each year.
Traditional automotive companies see value in what you're doing. Why is that innovation coming from the outside? Why are they looking from the outside to bring in this type of vehicle performance improvement?
Very good question. So it's, of course, if you look at the motor, an electric motor, this is the basic idea of an electric motor is more than 150 years old. So it should be, or in the mind of many people, it's like that there should be no room for innovation. Because, there is this motor and it's 150 years old, and what what can you do better on such an old system? And but if you look into specific applications of technology, and you see how complex an electric vehicle is and how complex a specific adoption of the technology is for a use case. And in this case, it's the use case of an electric vehicle going as far as possible with a given energy. Then you see that if you dig deep into the topic, you see that there is always some room for innovation, or some space for innovation, we always call it. And in our opinion, it's more easy for a startup like us without all those legacy components from the internal combustion engine driven industry. It's much easier to innovate in electric motor and to bring such innovations to the market.
What are some of the biggest challenges that you have?
There are two main topics. The first one is hardware. And hardware is really difficult to realize as a startup. Because, related to hardware, it's you start with a prototype. And then you do this testing of a prototype. And then you do the next prototype. And you do testing again. And then you go to a customer and make some adaptations. And you build a new prototype. And you do testing again. And then in the automotive industry, there is a process, an established process of like an A sample, a B sample, a C sample. And this process of bringing new hardware into the market easily can take like 5 to 6 years. And so for a startup, you have this large challenge, or this really difficult challenge, that there will be no revenue until that point. Until you reach that point, you have to put millions and millions of euros into it, and many persons and many capacity into development. And this is why building up hardware in a startup is really difficult. And of course, on the other side, it's from a technology point of view, there are specific challenges. So like, especially when it comes to electric machines, the insulation concept, the cooling concept, and the combination of insulation with thermal cyclings in electric vehicles, with vibrations in electric vehicles, and to solve all these problems. But this is, I will not say it's easy. It's a challenge, and it's engineering, and you can solve these engineering problems. But you always have to keep in mind this other side, that you are spending a lot of money to that point where the first revenue comes in.
Is there anything that the OEMs, the ones that are ultimately going to use this technology, can they do to help accelerate this adoption? Because it sounds like what you're bringing to the market is going to have a significant impact right away in terms of what we're trying to do is move to a more sustainable future.
The most important point on that is you always have to gain trust. So the customers, the OEM, and the whole industry has to trust or believe into the things you're doing. So it's always important to reach milestones, to do some testing, to publish results, to compare results to what you have promised. Because especially in the startup business, it's always the problem that startups tend to overpromise. So they are promising higher efficiency, higher range gains, higher performance than what they can actually deliver. And this is really dangerous in such a hardware startup, because if you lose trust at some point, then it's going to be very difficult. So looking at the automotive industry, you have to be to a certain point open, and also open for a technology. It doesn't work if you say, okay, we have this box, and this box has some wonders inside it, and it adds 20% efficiency. This will not work. So you have to explain, and you also have to, of course, to trust the customer that he won't catch your technology and build it by themselves. So you have to have strong IP, and you have to really focus on be fast in gaining IP and apply for patents, because only if you have that, you have the possibility to be open and to explain your technology to the customers. Because just to say, okay, we have this new technology and it will work out, doesn't work.
No, I can agree because very few companies are, if they don't understand your technology, are probably going to be very unwilling to put it in their vehicle, especially around propulsion. Let me come back to something you said that really got me interested. Talking about internal combustion engines, been around for 150 years. I always like to think that the internal combustion engine, right, it got very good because it's had a very, multi generations trying to make improvements to the way we do that. Um, and then now the race for EV, right? And so you're seeing a lot more companies, a lot more competition, barrier to entry is less. How do you think about connected vehicle technology playing a role to help DeepDrive as it becomes, used within the automobile industry?
Everything has to be connected today. So especially looking at how do you gain data about the real usage of the vehicle? Because as I mentioned, so it's all about reducing cost. And at some points, you only can reduce cost if you reduce weight, take away material, reduce sizing of the brake or something like that. And so you have to know what customers or drivers do with your vehicle. And with today's, or especially in the last 20, 30 years, this data was in my opinion, not sufficient. So we have to be better in that data collection to derive for the next generation of vehicles the correct requirement, and how to build up the cheapest vehicle, but still fulfilling the expectation of all customers. And in that point, I think a connected vehicle can really help. And of course, in more obvious functions like all things connected to autonomous driving and all those stuff. But especially looking at our product, we would be interested in gaining data from how are electric vehicles used today.
So you're part of an industry that's helping build what I'll call a more sustainable future, a future that we all want to live in. What are your personal thoughts around, how quickly is Europe moving towards EV technology? Are they moving fast enough? And what are some of the things that they could do to accelerate the adoption of alternative methods of transportation that will lead to a more sustainable future?
So currently Europe is moving quite fast. So it gained a lot of speed in the past few years, and it still can be faster. I think what is still missing is, or an important thing that's missing is affordable vehicles. So currently look at especially the middle European market. There are only premium vehicles on the market. So if you want to have an EV with a range above 400, 500 kilometer, you have to spend at least 40,000 euro for it. And yeah, that's still not affordable for a large part of inhabitants in Europe. So there has to be a shift, especially in the next few years, towards affordable electric vehicles.
So, Alex, can you talk a little bit more about the technology that DeepDrive is bringing to the market, and give us a little bit more depth in terms of what the dual rotor technology and some of the motor technology that you're developing?
Of course, so this dual rotor e-machine technology is really a completely new kind of electric machine we are bringing on the market. So the basic concept of a dual rotor machine is, from an electric machine point of view, it combines the advantages of an inner runner and an outer runner into a single electric machine. So you might, from a very simplified point of view, you might think of it integrates two machines into a single machine. And so it can cut losses significantly and cut material usage significantly. So we end up with a very efficient, power dense, and cheap electric machine. So those are the main features of the technology itself. And the concept of a dual rotor machine is not new, so it's quite old. But until today, it was not possible to build such a machine because it has a really significant challenge in terms of mechanical strength. And this challenge of mechanical strength is what we are solving with our IP. And so this IP, or our core technology in the winding and the state of this electric machine, enables for the first time enables us to build such a dual rotor machine.
Fascinating. That's very interesting. Well, that's all the time that we have. I want to thank my guest, Alexander Rosen, for joining us to talk about DeepDrive and what it's like to introduce new innovative solutions into the automobile industry. Thank you, Alex, for joining us today.
Thank you, Steve.
Thank you for tuning in to Point B. Join us next time for more auto tech innovations and trends. Point B is brought to you by Sibros.